Yesterday we finished building this piece of crap, but today we have to fix this piece of crap. This holiday season, spice up your build with high-performance options from MSI like the MEG Z390 Godlike, which supports up to 4600 MHz memory, or their wide range of graphics cards from AMD and NVIDIA. MSI also has full product lines including barebones, workstations, gaming peripherals, monitors, and more. To see all that MSI has to offer, click the link in the description below. Just because you can do some things doesn't mean you necessarily should. I was a little concerned when I started building this system with how densely packed it was becoming, that there may be some cooling issues. In fact, a lot of you in my last video were like, hey, where are the cooling numbers? Where's the temperatures? Where's the benchmarks? Well, as I said in the end of that video, I said load all my operating system and stuff on there, and that's what we've done today. And what we have discovered is that there are definitely some cooling inefficiencies in this. So if you take a look right here, you can see just how densely packed it is. There's not a lot of room on the bottom. The feet only stand about 4 millimeters off the floor. So I've got it propped up right now because I can put bigger feet on the bottom to get more airflow in the, through the bottom of the case. This is an updraft case. Heat rises, therefore we are trying to kind of have the natural rise of heat give us some convection to where we're blowing the heat through the case and up through the top. The problem is, with the motherboard right there and the I/O shield, we lose some volume there. This pump uses up quite a bit of volume, plus it puts off heat into the case because of this heat sink. Our RAM takes up some volume, our power supply takes up a huge amount of volume, which means that much airflow going up through the bottom is already blocked. We have our ribbon cables along there, we have our tubing, which is pretty warm, we'll talk about that in a second. And then of course we've got the top radiator right here, which as you can see once again is blocked significantly by the ribbon cable. It's also blocked significantly by the power supply, and we are also taking the heat of the power supply and blowing it right into the radiator. So here's what this has given us. We have a GPU right now, a Titan X at stock speeds on water that's sitting at 55C. Not terrible, but approximately 10C higher than I would see them normally in a larger case with larger radiators and better airflow. So we already know that is causing us a problem in terms of just heat and saturation. Now I have 4 EK Vardar 2200 RPM fans on this. And even when I run them at full speed, we still sit about 52C on the GPU. Now the CPU, the 9900K, this was a little bit of a concern of mine, is a hot CPU. We know that it has the STIM or the soldered thermal interface material. We've also seen some reports that it's not good. Better than the standard thermal material, but they've taken something, made it slightly better, but crammed twice as many cores in the same small package. So basically you've got 8 cores and 16 threads worth of hyper-threading inside of a 1155 socket I think we're on, whatever it is. And it's a lot of focused heat. And even though I have a decent block and decent pump on here, the CPU, even at factory voltages, is getting extremely hot. So I'm gonna have to do a couple of things today. I'm gonna have to take this apart again, which I said in my last video, I hoped I wouldn't have to. Yeah, see how well crossing my fingers went. I'll show you guys right now on Cinebench. I will actually hit 100C at stock voltages. I've even downclocked it. I've got it running at 4.3 gigahertz on all cores. I'm not even letting any of the cores get to 5 gigahertz like the factory turbo will, because the factory turbo will go to 5 gigahertz on one core, I think it is, and like 4.8 on two, and then it steps down from there, right? That's the turbo, the Intel Turbo. I've turned off all of the ASUS features on this because what I found was that I was hitting 105C and throttling when I opened up Google Chrome. Now I've cleared the min-max on here so you can see, but the package is idling at 42 to 48C. It kind of moves around. We've gone as high as 54. We're not under any load. I also have the fans running 100% speed right now, as well as the pump. And you can see that our voltages here on the V-core is only 1.1. That's nothing. 1.1 degree or 1.1 voltage on a like an 8700K would have my temperatures under load be somewhere in the 50s. So if I go ahead and run the test right here, watch our cores. Granted, this doesn't have all, well, it does have all 8 cores. They're right there. So keep an eye on the core temperatures right there. 70s, 80s, 90, and 100, 101, 102, 104, and now we're throttling at 105. As you can see, if we look down here, I'm throttling 4 gigs, 3.9, 3.8, 3.9, 3.8 on some. So we are throttling. And our score was only a 1,781 because the CPU was throttling. I don't know. I feel like the retention system on the SwiftTech is terrible. So now we have to tear it apart and see what we find. So part of my issue with this pump block combo is the retention plate here. Is it sits off the back of the motherboard and it has these little like foam pads. The problem is those crush, and then as you can see, it sort of like bows. And I'm not sure we're getting a really good contact here on the block, but the only way we're gonna be able to check that now is actually take it off. And I found it easier to remove the whole motherboard than to remove just the block, because this bracket's gonna probably fall off in the back. And as you can see right here, although there technically is a cutout right here, taking out the GPU and all that stuff does not make it necessarily easier to get to the back of this thing. So I'd rather just work on it outside of the case. It's just 4 screws. Okay, so right off the bat though, I'm not too happy with that thermal paste application. If you look at it, I mean, it doesn't go all the way to the edge. It's very thin. I suspect this one might need a little bit of lapping as well. What do we have to lose at this point? Yeah, it still spins a little bit. So that means the block itself could be high centered. Okay, so I lapped the CPU and lapped the block. It's definitely flat now, and cleaned out the micro channels underneath too, so we'll be changing out the fluid, obviously. So I'm gonna put this guy back together. I'm not expecting this build to obviously be amazing on temperatures. I just want something reasonable. And I dropped one of these screws, and I have to find it. I've always got a screw loose, if you know what I'm saying. Okay, here we go. Loop is together. My own special formula mix, just drinking water and other concentrates. But I digress. Let's go ahead and start it up. You know why I was worried? I dropped coolant down inside of the power supply. Ah! Okay, so we're at 24C inside of Windows right now. All the same settings we had before, so much better. Let me go ahead and go back to my fan expert now and put the fan curve back to where I had it. Let's just go standard fan curve. All right, moment of truth now with Cinebench. Remember last time we ran this, it hit 105 on the package, 105 on some cores. It throttled way down to like 3.3 or something like that. I don't remember what it was. 4.3, 53, 57, 58, 59, 60, 61, 60, 62. And it's still sitting at 4.3. So this should be significantly faster right now. You hear how the fans aren't ramping up? I think this is a combination of a couple things. I think it was a combination of lapping both the 1873. I think we might be able to actually put this back up to like the 4.7 and then allow a couple of cores to go to 5 gigs like it's supposed to. But I think a couple of things happened here. One, it was clear that the temperature was getting too hot for the true fluid from Primo Chill, as after one day it was starting to clog up and like solidify, like gelify is the best way to describe it, inside of the microchannel, inside of the Apogee Drive 2. There's not a lot of space there, it's very thin, so that could really have been causing us a terrible inefficiency of the block. We changed out the fluid. We also lapped the CPU IHS as well as the block. I also lapped the IHS on the CPU as well as the base plate or the cooling plate for the block itself. And then we applied more thermal paste. I did the X pattern rather than just the P method like I did on the first one. And our temperatures are significantly better. So I want to try 5 gigahertz 1.2, but I don't think it's gonna be enough voltage. See if it crashes though. 77, 80C, 81, 82, 83. Fans kicked up. We are still 25C below TJ Maxx. And we know Cinebench pushes harder than like Adobe does. So right there, 2136 on our score. And our max temp on any core was 85 and 85 on the package. So 5 gigahertz all core, super doable. And Phil's laughing because he gets to play with this thing. This is his little travel rig, so of course he's happy. All right guys, we're gonna go. Thanks for watching this video. Sorry we had to do a third part on this, but these are the type of videos that are important because seeing us put it all together and stuff is one part of these builds. But when you have a problem, finding out the problem is just as important. And the other thing I changed, I forgot to mention earlier, was I came up with that better retention system on the back, because I told you how it was kind of bowing down. So I basically used plastic washers against the motherboard and then metal washers against the bracket, so there's no short, to make a shim basically so that it couldn't smash down. Because what I feel is happening is I feel like there was a little bit of a bowing happening with the bracket on the top, which was causing us to not get a good even seat of the block versus the CPU. So we lapped it, didn't really polish it, it was pretty shiny. Lapped the CPU block and came up with a new retention system, changed out the thermal paste, changed out the coolant, and this is what we've got. I think most of the improvement we saw today though was specifically the retention system and the lapping of the CPU. So there we go. I feel so much better now. I was worried I was gonna tear the system apart and then be like, guys, I'm sorry, but yeah, we're done now. Thanks for watching, guys, and as always, we'll see you in the next one. Now, a lot of you guys really like this small form factor build I did, but if that's not your thing and size matters, then you're definitely gonna wanna check out this one.